Hi students, this video is on chapter Light, Reflection and Refraction part 5. Now in this video let us discuss about the refraction of light. Now what is refraction of light? When a ray of light travels from one medium to another medium of different optical density, it changes its direction. This phenomenon is called as refraction of light, or in a simple way, change in path of a light ray as it passes from one medium to another medium is called as refraction of light. That is, change in the direction of light when it travels from one medium to another medium is called as the refraction of light. So in this figure you can see here, AO is the incident ray and OB is a refracted ray. That is, AO is incident ray and OB is a refracted ray, and ON is normal to the refracting surface at the point of incidence, and I is the angle of incidence, R is the angle of refraction. So here in this case a ray travels from air medium to glass medium, it changes its direction. And when a ray of light travels from rarer medium to denser medium, it bends towards the normal. And when ray of light travels from denser to rarer medium, uh, the ray of light bends away from the normal, away from the normal. So this case indicates that is rarer to denser medium, and this one denser to rarer medium. So when a ray of light travels from rarer medium to denser medium, it bends towards the normal, and when it travels from denser to rarer medium, it bends away from the normal. That means in case of rarer to denser, angle of incidence is what, I, and angle of refraction is R, and I is greater than the what, R, and in case of denser to rarer, I is less than the R. And what is the cause of refraction? The speed of light is different in different media, that is, the more in rarer medium and comparatively less in denser medium. So what happens when light enters a denser medium, its speed reduces and it bends towards the normal, and when it enters rarer medium, its speed increases and it bends away from the normal. This is the main cause of refraction, that is, change in the speed of light. Now let us see some common examples for the refraction of light. First one, the letters. The letters appears to be raised when viewed through a glass slab placed over the document because of refraction of light. And one more example is what you can do it in your own. And the pencil partially immersed in water appears to be bent because of the refraction of light coming from the part of the pencil that is under water. This is also common example, and you can do it your own. And one more is what, when the lemon is placed in a glass containing water, it appears to be bigger than its actual size when viewed from the side view. So these are the common examples for what, the refraction of light. Now let us discuss about the refraction of light through a rectangular glass slab, parallel sided glass slab. So what is lateral shift or lateral displacement? When a ray of light passes through a parallel sided glass slab, the ray does not undergo any deviation, rather than it gets shifted to one side. This sideward shift is called as the lateral shift. So in this case, what happens in case of a parallel sided glass slab, the refraction takes place twice. First, when uh, ray enters the glass slab from air, and second one when between what, the glass and air interface. So what happens when a ray of light passes through a rectangular glass slab, it gets bent twice at the air glass interface and the glass air interface. So now what happens here? In the figure you can see AO is incident ray, that is between what? Air glass interface, and OB is refracted ray. And the next what happens, this between glass and air interface, that BC is the emergent ray. So this is the direction of incident ray. Now what is lateral displacement? That is the perpendicular distance between the emergent ray and incident ray, the direction of incident ray when the ray of light passes out the parallel sided glass slab. So this is called as the lateral displacement or lateral shift. This perpendicular distance is called as what? CD. This perpendicular distance is called as the lateral displacement or the lateral shift. And the next point is about the laws of refraction. The refraction of light occurs according to the laws of refraction. The first law, the incident ray, the refracted ray, and the normal to the refracting surface at the point of incidence all lie in the same plane. This is the first law of refraction. And the second law is the ratio of sine of angle of incidence to the sine of angle of refraction is constant for the given pair of media and a given color of light. This ratio is constant, that is sine I divided by sine R is equal to constant, and this constant is called as the refractive index. This constant is called as the refractive index, and it is usually denoted by the symbol n letter, and that is denoted by the what? The letter n. Now what is refractive index? This is also an important term. The extent of the change in the direction that takes place in a given pair of media is expressed in terms of the refractive index. Now we can write the formula for the refractive index also. The refractive index of second medium with respect to first medium can be written as n21 is equal to n2 divided by n1, that is equal to sine I divided by sine R. The second law of refraction is also known as the Snell's law of refraction. As the light propagates with different speeds in different mediums, so the value of the refractive index for a given pair of media also depends on the speed of the light in two media. So we can write the refractive index formula in terms of velocity of the two medium also. Now let us see the expression for this refractive index in terms of velocities. The refractive index of second medium with respect to first medium in terms of velocity, n21 is equal to speed of light in medium 1 divided by speed of light in medium 2, that is equal to v1 divided by v2. Similarly, the refractive index of medium 1 with respect to the medium 2 is given by n12, that is n12 is equal to speed of the light in medium 2 divided by speed of light in medium 1, that is equal to v2 divided by v1. Now what is absolute refractive index? What is absolute refractive index? The refractive index of a medium with respect to air or vacuum is called as the absolute refractive index. The absolute refractive index of a medium is simply called as its refractive index. If c is the speed of light in air and v is the speed of light in medium, in a given medium, then the refractive index of the medium n is given by n is equal to speed of the light in vacuum or air divided by the speed of light in the given medium, that is equal to c divided by v. Hence, for any two media, the refractive index of the second medium with respect to the first medium is equal to the ratio of the velocities of light in the mediums. Okay, in the next part we will study about the lenses.